in my role, when I get to speak to any customer, right, where we are looking to either integrate ImageKit or we are, let's say, having a general conversation about web performance, right? As a developer myself, I have been a software engineer in the past, right? So as a developer, a lot of our focus is usually always on improving web performance, right? We would have our management tell us that we need to improve our page speed scores, we need to improve our lighthouse scores, right? And that's what we focus on. But how do we improve performance for our website? We usually don't take a look at quality, right? Quality is usually left off as an afterthought, that someone from maybe from marketing or from management would come and tell us that, hey, the image doesn't look good, right? What can we do about it? So quality is usually left out as an afterthought, and we always focus on performance. But then in the current situation, we actually need to balance both of them, right? We need to find the right balance between the visual quality of images, how do they look on a user's screen, and how quickly they can load, right? And the reason for doing this is that it has multiple benefits. I've just listed down the top three on this page. One, obviously, you are able to deliver a better experience to your customers, right? A customer's experience, if let's say if they're shopping online or if they're reading your content online, a customer's experience is not just the page load time, but then actually the content that they consume as well, right? The products that they see. Now, imagine someone shopping on an e-commerce store and looks at a really poor quality of product. They would not buy that, right? It's after all, it's only the product image that they get to see before making a purchase, right? So it's really important to deliver a good user experience. We do focus on the visual part of that experience as well, apart from the performance, right? What it would also help you do is that when there are, let's say, 10 other companies like yours who are, let's say, in the same domain, you have your competitors in the same domain. If you are able to deliver a good homogeneous experience across, let's say, desktop, across mobile web or mobile apps, your experience stands out against your competitors. That means any user who comes to your product would, leave probably as a fan of your product, and, would recommend your product or your website to their friends, right? So that means that it would help you stand out against your competition, get you more word of mouth growth. So that's great for your business as well. And the third most important reason, and this is perhaps the most important of the three reasons that are listed here, is that helping balance the visual quality and the performance is actually more important now, given that most of the traffic on our websites, or let's say most of the internet access, happens on mobile devices, right? On an average, every website or every you know app that we have, apps obviously is mobile only, but then even for websites, almost 60 to 70% of traffic comes through mobile web. And mobile web presents a difficult yet an interesting opportunity for us to, let's say, create a great experience on that device. So we really need to start optimizing that visual experience for mobile devices for those 60-70% of customers who are going to access our website on their mobile device, right? We need to really work on that. And that is something that we will go in depth in this webinar as well, right? Our objective in this webinar is to go from an image that's there on the left. It loads really quickly, but then it is not great in terms of performance. I will probably just zoom into it a bit as well. If you look at the image on the left, the text is a little blurred. The edges are a little blurred. I mean, you can read it, but then if you compare it to the image on the left, the text is a lot clearer. You can easily make out the brand. The edges are very sharp. So our aim right now in this webinar would be to find out ways in which we can go from this image on the left to this image on the right in terms of quality, while we still maintain the web performance. And for determining that, are we able to maintain web performance or not? We're going to be using Google Lighthouse, which is now sort of the standard for measuring web performance on the internet. So we would be using Google Lighthouse to measure performance, and we would be looking at the images as they show up on our screen, and we will compare the images in terms of visual quality on our screen, right? We do have a demonstration ready, right? So in this demonstration, what we will do is we have a two-column layout. I'll just increase this a bit. We have a two-column layout, which has quite a few different images on the left and on the right. These are sort of representative of images that you would generally see on your on any typical website, right? These are product images, books, clothes, etc. So there are a lot of different images that you can see on this website right now. What we are going to do is we are going to keep changing the images on the right? Right now, both of these images are the same, right? They are loading from the same source. But then in the course of the webinar, we're going to change the images on the right so that we can visually compare it to the original image where we are starting off from, which is on the left, right? Uh, let's quickly look at, what is it that we have implemented right now on this demo page, right? So the images on the left and the right, as I said, they're coming from the same source. What we have done is we have pre-resized some of the images. We would be sharing this code after the webinar as well, so don't worry about this. We have basically pre-resized some images to some small images, which is 300 by 300 pixel, and a few large images, right, which is 800 by 800 pixel. I'll come to this later on. But then what we are trying to do is we're trying to mimic the general way in which we generally deliver images, right? We always start off by optimizing the experience for one of the devices. Let's say we want to optimize the experience that we deliver on desktop devices, right? So on my desktop device right now, the image that I need, for example, in this case, the image that we need is 289 pixel by 289 pixel in size. And what we are loading right now is a 300 by 300 pixels, right? So it's very close, right? We are optimizing the experience for our desktop device. That's how most of the companies that we have seen with, that's how we start, that the image should look fine on the desktop device. And then on mobile, there are two possibilities. In some cases, if customers have, let's say, or if your website has a mobile view as well, you would probably be using a different image for mobile and a different image for web. Or if you have a responsive website like this one, you would be using the same image, right? So we need a 66 by 66 pixel image, but then we are using the same image that we used on desktop web, which is 300 by 300 pixels in size. And this image right now, it's loading from the same folder that I just showed in our code, where all the images are checked in under the small folder. Every image has been pre-resized to a 300 by 300 pixel height and width. They have been compressed a bit for the web. So that's how we're going to start, right? A pre-resized compressed image, right? Now let's look at this in terms of performance. First of all, I have already run some Lighthouse reports, which you can access in Chrome from the network panel itself. This is a report for desktop, right? So obviously in desktop, you won't see that image resizing is a problem, right? So properly sized images has been marked as green, the audit passes, without any issues. If you look at this on mobile web, the other report that's there, resizing is indicated as an issue. It's not a very big issue, but then you can still save 100 kilobytes in terms of size if you were to resize your images correctly, right? So you would see that every image that we are loading, it is possible to reduce the size of every image, right? And that's true, right? Because when we started off with the image on the left, right, we started off with the image that was 300 by 300 pixel in size. That was perfect for desktop web, but it was a larger image than what we needed if we look at a mobile website, right? So on mobile website, the performance is taking a hit. Let's look at it in terms of quality. And what I'll do is I have a extension installed, because just to zoom into the images so that we can look at, how does the quality compare. So if I zoom into the image on the left, right, and right now both the images are identical, so I'll just zoom in on one of them, you really cannot make out the text that's written, right? So I know for a fact that this is a Rolex watch, and this is probably master, or I can read the digits, but then I cannot read the rest of the text, right? So it's not really that great in terms of visual quality, right? And that's the problem most websites have, that we compress the images, we resize them correctly, but then we really don't look at the visual quality that we are delivering, right? And when, let's say, someone from our team says that, how do we improve the visual quality, right? What should we do to improve the visual quality? A lot of times, people just start loading larger images, right? They start loading larger images everywhere. For example, in this demo, if I go to the the code of this, we are, as I mentioned, we are basically placing an identical image in both the columns. What I'll do is in my right column, I'll start loading a larger image, right? And this is something that I've already written before the demo. So product image is actually the small image, the 300 by 300 pixel that we have checked in. Whereas when I'm now going to use product large, it would be the larger image that we have checked in, right? So we have large images checked in. These are 800 by 800 pixel in size, right? Now, let me save this and let's reload the page. I'll go back to the desktop view and let's reload the page and now compare the image quality first, right? I'll use the same tool. Again, the image on the left, I cannot read the text at all. The image on the right, it's very clear, right? I can read out its perpetual date, GMT master, etc. Let's look at some other images as well, right? Maybe let's look at this one. If I look at the image on the left, the pattern on the dress is not really very clear. There is a lot of blurriness in this area, even around the face, the features are not that clear. Whereas if I look at the image on the right, the features around the face are a lot clearer. The dress itself, the pattern on the dress, and if you're an e-commerce brand, what you actually present in your product, right? This is a very good example of if you deliver the right quality image, your products would look a lot better for your users and it would help them make that purchase, right? Let's take another example, right? Let's take a look at this book and this would make it very clear. The image on the left, the original image that we started off with, it's impossible to read the text on this one. Whereas if I look at the image on the right, I can easily make out that this is 3. I can read even the first paragraph in this particular image. So the image quality has really gone up, right? Great. We have been able to solve image quality, but we know we are now loading larger images. So I'll just reload this page in a different tab and let's run a test, right? In terms of performance, that how does this work, right? Is this good for performance or not? We know it is not, but then let's just run Lighthouse and see how bad is it, right? For desktop and for mobile devices. Generally for desktop devices, you would not see a really big issue in terms of resizing. You would see that more on mobile web. For example, uh, like I said, desktop would not show any issue with the images. But then if you go to mobile web, you should start seeing that the images are significantly higher in size, and Lighthouse should be able to pick this up as an issue. Let's just check. Right. So properly sized images has become now a major issue on mobile web, right? So we were able to solve for quality on desktop, but then if we are going to use the same image on mobile, the quality takes a hit, right? So we really need to figure out a way, if we have a responsive website, if we're going to be using the same image tag on desktop and mobile, then how do we basically load the right image on every device and still balance the visual quality, right? And for that, we'll basically use a concept called responsive images, right? Responsive images would help you load the right size on every device, specific to what that device needs. And it will also take advantage of how the browser loads images, right? Because browsers are tuned to basically load your page as quickly as possible. So with responsive images, we would be able to take advantage of that browser prioritization for loading the right image on every device without having to write any sort of JavaScript code, which would actually could slow down your page. We'll take advantage of a standard browser specification, right? We'll first look at a demo and then I will pause maybe for a few questions, but then let's first look at a demo of how this would work. So instead of product large, I have already written a code which would help me deliver a responsive image. I will come back to the code a little later in this demo. I have this here ready, but then now that I have saved it, I'll just give this page another load. And let's look at the network tab, that what does the browser load, right? And let me just go back to normal zoom, reload this page again. Right, so now if you look at my desktop screen, I have the normal image, right? The one which does not have a parameter at the end. This is the one which is there in the column on the left, right? This is the original image where we started. Whereas on the right, the browser is now loading a 600 by 600 pixel image, right? We will get to this. How did we get to a 600 by 600 pixel image? But then it's loading a 600 by 600 pixel image. If I change this to a mobile view and reload the page again, the browser now loads a 300 by 300 pixel image, right? So I'll maybe just move this a bit. This is a 300 by 300 pixel image, right? So we're able to see that on two different screen sizes, desktop versus mobile, the browser was able to load a different image size. Now let's compare the quality, let's say, of these two images that we loaded on the left and on the right. Let's start with the watch because it was the easiest to look at quality over here. I'll zoom into the images a bit to look at the quality, right? So the one on the left, not readable. The one on the right is fairly readable, right on the right. So we are now able to see that in terms of quality, we are doing fine on the image on the right. Whereas, in terms of performance, we are able to load different images on web and mobile. I will pause now for a bit. I'll let the questions come in, and then we will start going deeper into how this responsive image tag is built. How does the browser look at it? How does it load? And we will also run a test on Lighthouse to see how does this impact our page load performance, right? So I will run the Lighthouse test in parallel, but then I'll just pause for a couple of questions that are there. Okay. So Prem, to basically benchmark the same on mobile, you can basically use the same Lighthouse tool that you have in Chrome. I don't think it's an external extension because it's available in the latest versions of Chrome built in. I think I do not have any such extension installed. If you go to Lighthouse and if you click on a new report, so you get an option of where do you want to test it, whether it's mobile or desktop, and you can select the categories that you want to test. Images come under the performance category, the part that we are looking at right now. So you can run it for either of the devices, depending on where you want to benchmark your performance. You can also use, instead of, let's say, using Lighthouse, you can also go to Google PageSpeed because Google PageSpeed also uses Lighthouse engine in the backend to run these tests. So you can go to Google PageSpeed to run a test, just give it a URL and it will benchmark your website for both mobile as well as desktop. Okay, for Android native applications, again, this webinar that we are doing is for the quality that we render on the web. The principle, let's say, that we will just cover, as we move forward in the demo, can be applied to any app, Android app or iOS app as well. I do not know how to benchmark it per se, but then you would be able to apply the same concept that we discussed under responsive images to deliver the right image size on Android apps as well. And we know for sure that as a practice that it would be, if you implement it correctly, it would be the right thing to do on an app. But then I do not know a way to benchmark it on Android native applications. We'll take a note of it and I'll probably get back to you on email on how to do that on Android native as well. Any other questions at this stage? Okay, what's the difference between 300 by 300 image with JPEG and WebP extension? Okay, I will come to this when we start covering responsive images, but then the difference was that I am actually using ImageKit to render the resized image. The one that was, let's say, resized using these parameters, I was using ImageKit to do it. ImageKit automatically converts an image to WebP as well, right? But then that does not really have an impact on the quality that you are displaying, right? So even if, let's say, ImageKit were to deliver a JPEG image, the quality would still be fine. And even the Lighthouse reports would remain the same. The ones that we are going to just run in a bit, the reports would remain the same, right? It's just because ImageKit is able to convert the image to WebP that it is getting converted to WebP. Right. So I'll just come to that in a bit. No, so the quality is not better because of JPEG being converted to WebP. This principle is applicable across all formats. Can you show the size of images? Yes, please. The size of the images, it would go up a bit, right? No doubt the size would go up a bit, but then we will look at that even Lighthouse actually doesn't actually indicate anything that it's wrong. It's the right practice to do if you're trying to balance performance and quality. And that's the, in fact, the agenda of the webinar, that we will do something with responsive images that is actually good even with Google in terms of performance, right? So it doesn't impact performance, so you can be sure of that. And let's quickly get to the code, right? So it will probably answer a lot of questions that are now coming up. Let's look at the code, that what did we do in a responsive image, or in fact, let's look at what a responsive image tag actually is, right? Uh, when we were delivering a normal image, right, the image that we are delivering on the left, we provide the browser with just a single URL, right? This is the source, right? That is what we provide the browser. We provide it with a 300 by 300 pixel image, right? Whereas in a responsive image, we provide the browser with a single source, but apart from that, we provide it with a list of images, right? And these images, all of them are at different widths, right? Or different sizes. For example, if we go back to our code, right, where we have implemented responsive images, I have provided the same small image, the same 300 by 300 pixel image in source, but then additionally, I am also adding a source set. And here I'm actually using ImageKit to be able to generate different sizes of images. We are generating images in 4 sizes, 100 pixel wide, so 100 by 100. This is what resizes an image to a 100 by 100 image. We resize it to 100 by 100 and we tell the browser that it's a 100 pixel wide image, right? This is what tells the browser that how wide the image actually is. In the next one, we have a 300 by 300 pixel image and we tell the browser that this is 300 pixel wide. Similarly, 600 by 600 and 800 by 800. These are the 4 sizes that we create and we tell the browser what size is it, right? Once we have given the browser these sizes, and let's even look at it in the browser as well, right? If I inspect the image on the right, you can see that there are now 4 sizes that are getting that are available in the source set, right? So we give the browser a list of URLs, and we also tell the browser how to render these 4 URLs, right? How would the browser know that which of these 4 URLs is it supposed to pick up, right? So sizes is used to give this specification of how does this image appear on different devices. For example, let's look at our code. So in my code, the sizes specification that I have given is that if this is a mobile device with width up to 480 pixels, I need a 100 pixel wide image, right? So if I go to the mobile view, if we look at the image, we actually need something smaller than 100 pixel, right? So it's 69 by 69 pixel is what we need. But then on the safe side, given that there would be different devices, there could be a device at this width as well. Let's say on this device, we need an 85 by 85 pixel image, right? So on the safe side, I have said that on anything that's less than 480, I need a 100 pixel image. On every other device, I need a 300 pixel wide image, which is basically our desktop view. If I go back to the desktop view, I need a 300 by 300 pixel wide image over here, right? This is a very simple specification that we have given just to simplify it for a demo. Otherwise, it can be as complex as this one over here, where we are specifying 4 different levels of screen sizes. So it is possible that your layout is different on mobile, it's different on tablet, it's different maybe on a laptop, and then maybe different on a larger desktop screen, right? So you can specify as many specifications as possible. You would see that the specification here is not pixel, but VW. VW is basically viewport width, right? Viewport width is your browser's width. So instead of specifying a specific size in pixel, we are specifying the size relative to the browser width if we are using VW, right? So these are the 2 options that you can have: specify it either as pixels or specify it relative to the viewport width, right? So source set is the list of images on different widths. Sizes is the specification of how the image should be rendered. And source is actually just a backup if the browser does not understand source set or sizes, it will fall back to using the source, right? So your image tag would render on every browser, uh, and on browsers that support SRC set and sizes, the browser would use these two, right? And almost 96% of browsers support SRC set and sizes. So you should not be worried at all that this would not work on a lot of devices. This would work on 96% of devices. And on the 4% where it does not work, the browser would load the image from the SRC tag, right? Let's look at the behavior of what is actually happening. Why is the browser loading the image that it is loading, right? I will go back to 100% zoom because we do not want to look at quality as of now. Let me just reload the page again, right? So the browser is loading the regular images on the left, and it is loading a 600 by 600 pixel image for the ones on the right, right? And you can also check this. If I select this image, if you hover on this, you would see that the browser is loading a 600 by 600 pixel image. And it also shows you what's the current source, right? So the current source has W600, H600 in the URL. So out of this list that you have specified, it tells you which URL is it actually using to render the image, right? And the reason it is doing that is on my desktop device, I have said that I need a 300 pixel wide image, right? But the screen that I am on, it's actually a high density screen, right? I'm using a MacBook Pro. You would have heard terms like retina displays or high density displays, especially for mobile phones. It's true for some of the laptops as well. Just a few laptops have high density displays. So the browser also takes that into account, right? The browser takes into account if this is a high definition display, it automatically takes it into account to load the right size. So my device has a device pixel ratio of 2, right? So if I say that I need a 300 pixel image, the browser knows that because my device pixel ratio is 2, it needs to multiply it by 2, that is go to 600, and it looks at the list that is available. It finds an image at 600 pixel width and it loads that. What would happen, let's say, if the browser does not find an exact size that it should be loading? Then the browser would actually go to the closest one. For example, let's say if the size had come out to be 500 pixel, the browser would have gone on to the 600 pixel wide image because that would have been the closest one, right? So you really do not need to handle every scenario to the exact pixel. You just need to provide a list and the browser would automatically go to the closest one, right? Now let's go to mobile and see what would happen, right? Now our expectation is that we have said that on mobile, this should be 100 pixels wide. Because my screen is of twice the density, it, it basically needs a 200 pixel wide image as per our specification. If I reload this, because there is no 200 pixel wide image that I have specified, the browser would now load a 300 by 300 pixel image. It should do that. So let's just reload this quickly. And if you see, every image is a 300 by 300 pixel image now, right? Let's make a bit of a change to the code. Instead of loading a 300 by 300 pixel image, let's say I load a 250 by 250 now, right? I realize that, okay, I do not want a 300 pixel wide image. Let's load a 250. Let me give this page a load again. And now you would see that the browser picks up the 250 by 250 pixel image. What would happen, let's say, if I were to not provide this level at all? Let's say my tag is just this, right? What would the browser do? It now has three options: 100 by 100, 600, and 800. Now, as per our specification, the browser should have loaded a 200 pixel wide image, right? So 100 multiplied by 2. It does not have that in the list. It does not even have a closed size. The only options that the browser has is either to load a 100 by 100 image or a 600 by 600 image. So the browser now automatically balances for performance, right? If it would load a 600 pixel image, that would be really large, right? It would take a lot of time to load on that device. Instead of going for a 600 by 600 image, the browser automatically goes to a 100 by 100 image, right? So in a list, given whatever list you are using, if you just give this list to the browser, it would automatically determine which image to use on which device, right? And let's understand what, I mentioned about DPR or high density screen. So let's just quickly look at what a high density screen actually means, right? On a normal screen, which is probably, let's say, a normal laptop or an Android device, some of the low-end Android phones that are there, the let's say you have an area which has 10 pixels across the width and 10 pixels on the height, and you have a circular image that you have to show, right? What happens on a high density screen is that in the same area, right? So the physical area is the same in terms of centimeters, let's say it's the same, but then a high density device put back more pixels in the same area, right? So it would have, let's say, 20 pixels along the top edge and 20 pixels from top to bottom. So now instead of having 10 cross 10, 100 pixels, it now has 20 by 20, 400 pixels in the same area. Similarly, if the device is 3x as dense as a normal device, it would have 30 by 30, so 900 pixels in the same area, right? So now if you want to maintain the sharpness of the same circle on every device, you would need to load thrice the size of the image that you load on a 3x device compared to what you load on a normal device, right? So the browser is taking this also into account, that if I am accessing it from a high density screen, it is actually multiplying the specification by my device density to determine. Now, let's say when I switch from mobile to desktop, you would see that the browser actually automatically triggered a load for 600 by 600 pixel images as well, right? So there are 100 by 100 pixel images which loaded when we had the mobile view. As soon as switch to desktop, it loads a 600 by 600 pixel image. So the browser also takes into account any screen width changes that are happening in real time. If they require a new image, the browser would load it, right? So this is basically the best way to let the browser, load or decide what's the right image that it needs. It's taking multiple factors into account. It's taking your performance into account. It's taking your screen width, display density, everything into account to load the right size from that list. Now let's look at it in terms of performance, right? Because that's what the agenda of the webinar is, that we have been able to solve visual quality, and we'll probably let's take a look at that again. We have been able to solve visual quality. The image on the left, not readable. The image on the right is rarely readable. I'll probably just drop it down to 0 zoom, load it again, and compare the visual quality maybe on a different image. Let's look at maybe this book, right? The image on the left, the text is not very clear. You can easily see some noise around each alphabet, whereas the image on the right, a lot clearer than what we have on the left. Let's look at this particular bike, let's say. The image on the left, you cannot really make out the brand name that's there on the bike, whereas the image on the right, you can easily read that this is Triumph. It is possible that on your video quality in this webinar, you're not able to look at this difference, though it should be clear. But then once we share the code, you would be able to run it on your local systems and see this different for yourself. For example, on this phone screen, the text on the left, not very clear. You cannot even make out the names of the apps. But then on the right, you can read the names of each app, and the text on the top, social networks, is a lot clearer as well, right? So quality is great. Now let's run the lighthouse test and see if that would be fine. Let's do it first on mobile, because that is where the performance challenge was. So right. So for mobile device, let's see, right? So we do not have any problem with resizing images. Let's see if it's a passed audit. It is a passed audit. It shows potential savings of 100 kilobytes, but then it's actually because of the images on the left, the ones that we started off with. You would not see a resized image coming from ImageKit under this warning, right? So the images that we are loading on the right, they are fine, right? None of them are picked up in the warning. Let's run the same test on desktop, and hopefully this would be fine. Right, so let's scroll down. Again, no problems with the images. It should come under a past audit. It does show properly sized images on one of them, which we can probably take a look at. Why does it show for a 10.7 KB? But then most of the things are now clear. The audit is green, right? So we have been able to solve for quality, and we are able to solve for performance even by Google's benchmark. A few things you should keep in mind when, we have already covered the advantages of responsive images. A few things you should keep in mind when you are building a responsive image tag is that when you're specifying this list, right, you should not really try to specify a list that is longer than maybe 4 or 6 different sizes. The reason for this is that if you start introducing more steps in between, there would not be a very huge difference between, let's say, a 250 by 250 pixel image, then a 400 by 400, and then a 600 by 600, right? You're not, they would not be very different in terms of the size in kilobytes, right? So you would not really benefit a lot by loading one or the other, either in terms of size or in terms of quality, right? So in terms of quality, the browser would load maybe the 600 by 600 pixel wide image and it would work fine, right? So you would not gain a lot, but then you stand to lose a lot, right? If you introduce a lot of different sizes, this means that users on different devices are now requesting different images, right? If you're using a CDN, right, to deliver your images, this would mean that not a lot of content can be cached in the CDN, because now for the same image, instead of having 4 sizes, maybe you have 10 sizes for the same image. It would be difficult for a CDN to cache all of them in its cache. So your performance could take a bit of a hit at that time. The other thing to remember is to specify this size specification for sure, right? Without this, the browser does not know how it is supposed to render the image, and therefore it does not know which URL to pick up, right? So just be sure that you mention the sizes, and you know your layout, right? So you would know that on my mobile screen, what's the size I need, on my tablet or on my desktop screen, what are the sizes I need. Just specify those sizes, but then make sure you specify it so that the browser can load the right size. And you can actually use your, let's say, your Google Analytics and your actual web page layout to determine what these steps should be, right? So if you're getting a lot of traffic from mobile where you need a 100 pixel wide image, because I need a 100 pixel wide image, I have one step at 100 pixel. I know I would need, let's say, twice or thrice the size for higher density screens. So I have steps around 200. I had it at 300 when I started. So there were steps around 300. On desktop, I know I need a 300 pixel device. So I had a size at 300, 600, which is twice, and then 800, which is slightly lower than thrice, right? So you can use this data, that where are your users coming from, whether they are coming from mobile devices. In GA, you also get the actual viewport size of those devices. So you can use that data to build your responsive image tag, right? We do have an extensive guide, which we will share after this webinar in an email that comes out to all of you, that you can go into the depths of how to construct a responsive images. It does cover a lot of other technical details as well, which we could not cover in this demo. So you should definitely go through this. We have a separate guide which talks about some more tricks that you can use for e-commerce to even reduce the image size even further while still maintaining the image quality. And there is a sample application, the one which we are using right now, with all the code, all the images checked in. It's available on GitHub, and we would be sharing the link for this right after the webinar, right? So you should probably have this later today in the evening or tomorrow morning. You should have all of this content with you. We did not cover a few more things, like there could be a possibility where you can use JavaScript to load the right image size. It's usually not a good practice to use JavaScript to load the right size unless you are using a client-side rendering framework, right? If you're using something like React or Angular on your front end, you can use JavaScript, but it's generally not a best practice. You should always stick to using responsive images. It's standard browser specification, very high performance, takes into account almost every factor that you could possibly think of, and it just works out of the box, right? You would not have to worry about writing the right JavaScript code for that, right?